No Gickerich. Francisco, will you sit down, please?
Kroger, do you want a drink too?
No, I'm good. Thanks, man.
Okay.
No Silva? Okay. Okay, for the first one, number one on your test review, it looks like this. Holy crap, there's a lot of these. What if I don't want to?
There's a lot of what?
Oh, I already know I got one.
Do I have another one? I swear.
Did you see my name?
Oh, they're up on the screen.
Oh,
This is the worst timing ever.
if I get one,
This is terrible.
I'll be so sad.
Mitzi?
Come on.
Come on, hurry up.
This is the worst. I don't know what the heck this is. Why don't they pull them out of art class?
I art in dark.
You guys need to hurry back. Good thing we're recording. Okay, guys, need to shut up. This is number one, 2x plus 1 over x minus 9. Okay, we need to find A, the domain. This seems really familiar. B, holes. C, vertical asymptotes. D, horizontal asymptotes. Other asymptotes. Y-intercept. X-intercept. And then we need to graph it. Okay, so let's get to work. How do you find the domain? Denominator not equal to 0. So x minus 9 cannot equal 0. Add 9 to both sides, so x cannot be 9.
Did you guys have any food?
No, we're hungry.
Okay.
Sorry to let you down. We're very disappointing. Okay, holes. How do you find holes? Holes is stuff that cancels. Is there going to be anything that cancels? So there are no holes. Vertical asymptote. How do you find the vertical asymptotes? Vertical asymptote is going to look very much like the domain. What's the difference between the way the vertical asymptotes? X equals 9. Yeah, you said the denominator equal to 0 instead of not equal to 0. Horizontal asymptotes. Do we have a horizontal asymptote or do we have a slant asymptote? How do you know? It's case 2 because it is 1 over 1. So what is, because it's the same, very good, so it's case 2. So it's a horizontal asymptote. What does that tell me about the other or slant asymptote? There's not one. What is the horizontal asymptote? Very good. I don't know who said that. That was amazing. Well said. Money, money. Okay. Now for the y-intercept. Y-intercept is really easy, right? There's the y-intercept. Negative 1/9. Right? And it needs to be written as an ordered pair. 0, negative 1/9. The x-intercept. How do I find the x-intercept? That's how we found the y-intercept. So numerator equal to 0. So 2x plus 1 equals 0. Minus 1. 2x equals negative 1. Divide by 2. X equals negative 1/2. That is not how I want to see it. What was it for?
We're just returning some stuff.
Makes me mad. What is the x-intercept? Negative 1/2, 0. Has to be written as an ordered pair. Okay, now we're ready to sketch a graph. To sketch a graph, we start with all of the asymptotes. Asymptotes first. So we have a vertical asymptote at 9. So vertical asymptote is way over here. Horizontal asymptote is at 2. Okay, there's our horizontal asymptote. X-intercepts. Then we go to the X and Y-intercepts. The X-intercept is X is negative 1/2. And Y is 0. The Y-intercept, X is 0. And Y is negative 1/9. So that's really, really close to the Y-axis, like that. So I have clues. Remember, graphing, it always follows the asymptotes. Okay? I know it's in this quadrant. Why? That's where my intercepts are. Very good, you guys. So it looks like that. Is this asymptote even or odd? How do we know that it's odd? Multiplicity of the vertical asymptote is 1. So it looks like this. Okay, let's do number 2. F of x equals x plus 6 over 3x squared minus 108. Okay, we need everything. Domain, poles, vertical asymptotes. And I'm just going to say horizontal asymptotes and then slant asymptotes. Y-intercepts, X-intercepts, and then we're going to graph it. Okay, right off the bat, what is our Y-intercept? It is 6 over negative 108, right? And we can fix that. Right, that's not good. We can divide the top and the bottom, I think, by 6. Right, so I'm going to divide the top by 6 and the bottom by 6. 108. Remember, there's no calculators. 6 into 10 is 1. 6, 48, right? 8. Right? 6 times 8 is 48. So this is 1 over negative 48. Where is that? What is this? Oh, it's negative 18, not negative 48. Thank you. What is this? This is the Y-intercept?
Pretty much 0.
It is pretty much 0, but that's not what I'm asking. What part is it? It is the Y value of the Y-intercept. Right? So the Y-intercept, negative 1 over 18. What is the X value? 0. Okay, that's the Y-intercept. What's the X-intercept? How did you get negative 6, 0? Comes from the numerator. Set the numerator equal to 0. Okay? What case is this? Why is it J-Lo? The numerator, the degree of the numerator is 1. The degree of the denominator is 2. It is little over big. It is J-Lo. So what is J-Lo? Y equals 0. What is that? Y equals 0. Very good, you guys. Slant asymptote? There's not one. Vertical asymptote and domain and holes, we need to do what first? We need to factor. So I'm going to pull out a 3, a GCF of 3. Then I have x squared minus, what's 108 divided by 3? We have to do some work. Let's do some work. 108.
What's 8 divided by 6 times 2? 36.
Okay. Good. Very good. Can I factor this some more?
Yeah.
So this would be 3 what?
Plus 6.
Very good. Okay, what happens now? We can kill x plus 6. What does that make? So I have the reduced version, x minus 6. Okay, what is the whole? So negative 6, the stuff that dies, I said equal to 0. What is negative 6? The x value of the whole. Very good. Okay. Now we need to figure out the y value of the whole. How do I do that? I take negative 6. Guys, coming back to class doesn't mean you get to be more disruptive. Okay, negative 6. I put negative 6 in for x. So I get 1 over 3. Negative 6 minus 6. Negative 6 minus 6. What is that? Negative 12. And times 3. 1 over negative 36. What is this? The y value for the whole. You guys are amazing. 1 over negative 36. Vertical asymptote. What's the vertical asymptote? 6 is not the vertical asymptote. X equals 6 is the vertical asymptote. What's the domain? X cannot equal 6. Is that it? And x cannot equal negative 6. Even though the whole died, I still can't have it. That's what makes it a whole. It died, but I still can't have it. Okay, I think we have everything. We're ready to graph. Okay, remember, a little number over a big number, that's pretty much a 0. But this is pretty much negative 0. So the whole is, well, let's start with the asymptotes. I'm sorry. Horizontal asymptote is the x-axis. The vertical asymptote is 6. Remember the rule with the vertical asymptote, or horizontal asymptote. Can I cross the horizontal asymptote?
Yes.
Can cross the horizontal asymptote. Can I cross the vertical asymptote?
No.
Cannot. Okay? So then we're going to plot all of our points. X-intercepts. The x-intercept is negative 6, so it's way over here. Oh, no, wait. What happened with the x-intercept? It died, so there is no x-intercept. There's not an x-intercept. It died. We found the x-intercept too early. The y-intercept is negative 1 over 18, which is a little number over a kind of big number. It's very close to 0. Right there is the y-intercept. We have a whole at negative 6, okay, negative 6 and negative 136. So the whole is right here. Right? So we have a pretty good idea what this graph looks like because of our asymptotes and the x-intercepts, the x and y-intercepts. There's no x-intercept actually. Okay, comes along, grabs the y-intercept, and goes down. Is the asymptote even or odd? It's odd. The degree is 1. That means it comes up here. Okay, that's what it looks like. Okay. Let's do number 3. X squared minus 4x. X cubed minus x squared minus 20x. I need to check. We need to check the bells. Love that. There are no bells on this test.
Yes.
Okay. We need to do everything, right? So, domain, poles. This is very, very similar to the test, you guys. Vertical asymptote.
Is it just going to be this on the whole test?
Uh-huh.
And there's only
Horizontal asymptote, other asymptote, or slant.
Wait, do we have to label these on the top?
It will say. It'll say. It'll have just like this along the side. Here, like I'll put up a. It looks like this. Like this is the test,
So that's the fact.
and it says it does like that.
You should have put up the end.
Okay, other asymptote, y-intercept, x-intercept, and then graph. Okay, really, really quick before we even do anything, we can find the y-intercept.
Yep.
How do you find the y-intercept?
It's just there isn't one
How do you know?
because the denominator is 0.
Because the denominator would be 0. Because the denominator will be 0, every term has an x in it, I know there's no y-intercept.
Can you explain that a little bit?
So, to find the y-intercept, what do I do with all of the x's? I make all of the x's 0, so I would get 0 minus 0, which is 0, divided by 0 minus 0 minus 0, which is 0. That's 0 on the bottom. Can't happen. No good. Doesn't work. Because there's a 0, the way Landon said it was perfect. Because there's 0 in the denominator, there's no y-intercept. That's all you need to know. Or you can look at it, and if there's an x in every term of the denominator, then it would make 0 in the denominator. That's bad. Can't have it. White out? Why? Yes? It's like the strip kind. Okay. How about which case is it? How do you know it's JLo? It's bigger on the bottom. It's a little over big. So it is JLo. So what's the slant asymptote? There's not one. How about what's the horizontal asymptote? Y equals 0. It's JLo 0. Okay, now to do anything else, we need to factor everything. Okay, so I can pull an x out. I have a GCF of x. What's left after I pull out an x? X minus 4. And on the bottom, I can pull out an x. What's left? Okay, then we can do x games with this. Okay, x minus 4. X minus 5, x plus 4. There's too much talking, you guys gotta shut up. Okay, does anything die? Are you sure?
Oh, X and X.
The x's die. So we have a whole. What is the x value for the whole? 0. Right? You set what dies equal to 0. In this case, you set x equal to 0. Okay, so the reduced form, x minus 4, x minus 5, x plus 4. How do I find the y value of the whole? I set all of the x's. I make the x value of the whole. x to find the y value of the whole. Does that make sense? So I plug in the x value for the whole. Okay? So it would be 0 minus 4 over 0 minus 5, 0 plus 4. So this is 4 over negative 4 over negative 20, right? Which would be positive 1/5. What is 1/5? Billion. I don't know how much you care, but I feel like Abby might want to do well on this test.
Why are you talking?
Because you guys are sitting there giggling and talking.
We're arguing about the way of whiteout.
Okay. So the y value of the whole is 1/5. Does anybody have any questions about that? Okay. Where do vertical asymptotes come from? The denominator, right? So what are they? What is we have 2 in this case. X equals 5 and x equals negative 4. That's my bad handwriting. Okay. What's the domain? X cannot equal 5. X cannot equal negative 4. Is that it? Not it. It's what died. What died is the holes. The x values of the holes will also be part of your domain. Does that make sense, you guys? Okay. Now we need x-intercept. What is the x-intercept? The numerator equal to 0, so it's 4, 0. We have everything. I think this graph is going to be considerably trickier. Because we have 2 asymptotes, 2 vertical asymptotes. 5. One of them is 5. The other one is negative 4. What's my horizontal asymptote? 0. Remember, we can cross, and in this case we do because we have an x-intercept. My x-intercept is 4. 2, 3, 4, so it's right here. Where's the y-intercept? There's not one. Okay? But we do have another clue. What's our other clue? The hole. And that's very important. Otherwise, we have no idea what's going on here. We don't know if it's doing this or doing this, but the location of the hole is very, very useful. 0, 1/5. Okay, that's positive. The hole is right there. Okay, that's very helpful. Because now we know, at the very least, the function is doing that. Okay, is it going to do that and then go up or go down? Can it go down? How could it go down? From here, could it go down? I see what you're saying, Justin. My God. So from here, can it go down? There's not another x-intercept. Brilliant. Brilliant, Autumn. So now we know it goes up. Why? There's not another x-intercept here. That's one of your clues. Okay, from here, it's going to go down. This asymptote is even or odd? It's odd. 1 and 1, so it does this. Right? Even or odd? Odd, so it does this. And that is what the function looks like.
So, is it actually straight?
It jumps right over the hole. But the hole, it will go up to that point, though. That's how we know where it is. Okay, let's look at number 4. Number 4 should be quick because, well, there's a lot going on. X plus 3, x minus 4, x minus 5, x plus 4, x plus 3. It's already factored for you, though. Okay, we need the domain, poles, vertical asymptotes, horizontal asymptotes, slant asymptote, y-intercept, x-intercept, and then we need to graph it. Okay, it's already factored for us, so this should be pretty easy. What is the domain? X cannot equal what for this one? 5, good. X cannot equal -4, and x cannot equal -3. Does anything die? Are you sure? X plus 3 dies. What does the dead stuff tell us? So what is the x value of the whole? -3, good. Okay, -3. Now I need to write the reduced form. X minus 4 over x minus 5, x plus 4. How do I find the y value for the whole now? So what died was x plus 3. Instead equal to 0. Thanks for asking, Autumn. So I put -3 in for x, -3 minus 4, -3 minus 5, -3 plus 4. Okay, -3 minus 4, what does that make? -7. -3 minus 5, -8, times, very important, times, -3 plus 4 is 1, times 1. So 7/8 is the y value of the whole. Yes, good. Vertical asymptotes. Where do vertical asymptotes come from? The denominator. Or you can think of it as excluded values, but don't get mixed up with the whole. Okay. So vertical asymptotes, what are they? X is not -3. That's the whole, right? That's what. So I would look at the reduced equation, the reduced form. Horizontal asymptote, or is it a slant asymptote? Which case is it? What's the degree of the numerator? 1. You can look at it as 1, or you can look at it as 2. 2 over 3, or 1 over 2. Either way, it's little over big, so it's J-low 0. Is there a slant asymptote? Y-intercept. What do we do for the y-intercept? Set all of the x's to 0. So that would be 0 minus 4 over 0 minus 5 times 0 plus 4. 0 minus 4 is -4. -5 times 4, -20. Positive 1/5. Right? So x is 0, y is 1/5. That's the y-intercept. How about the x-intercept? 4, 0. All right. Ready to graph. Start with what? What do we start with? You could start with the intercepts. It wouldn't make any difference. But for consistency, I'm always going to start with asymptotes. So 5. We have one at 5. One at -4. Okay. Horizontal asymptote is again y equals 0. Very important, you can cross the horizontal asymptote. X-intercept is 4. Y-intercept is 1/5. This looks very similar to the last one.
Very similar. Yeah, you got
Oh, the whole? Where was the whole?
-3.
-3. and 7/8. What?
7/8 is a fraction.
Is not right.
How do you grab 7/8?
7/8 would be less than 1. So I just have my curve a little bit wrong. Does that make sense? I just went up too fast. It really would be more like that. Get over it. Get over it. You heard me, Billy. Okay, let's do one with a slant. Let's do number 5.
Go back. We never did a 4-6 homework, did we?
You said that 4 or 5 was the exact thing.
No, we did do 4 6 1.
You didn't teach it to us.
I don't have notes on it.
Yeah, you didn't.
You put it on
That's
the
so
database.
big.
They're on Canvas, and there's a video, and I only
You were
record.
right. You didn't make
I only record videos in this class. So how did that happen?
Just 4-6 graph.
How did the video happen? Who made the video?
Me.
Billy made the video. Then you have Billy to blame for your 4 6. I promise we did it. Well, how does the video happen then? I have video evidence.
Show it.
I want to see it.
You can get on Canvas and look at it. It's right there. Okay. More importantly, we have a test tomorrow. Okay, we have to do domain, vertical asymptote. Thanks, Billy. That's a good point. Horizontal asymptote, slant asymptote, x-intercept, y-intercept. Oh, and I forgot the holes. Okay, how do we? What's our y-intercept?
It's gone.
2 fists. How did you get 2 fists? It's pretty much that. Make all the x's 0, makes them go away, so we get y-intercept of 2 fists. So the x value is 0, y value is 2 fists. Okay. What case is this? Dolly division. So we have a slant asymptote, we don't have a horizontal asymptote. We can do synthetic division. Okay? Let's do that right now. How do we do synthetic division?
You take all the 5.
What goes here? 5 goes here. What goes here? 1, negative 1, negative 2. 1 comes down. Oh, we have to check. Thank you. Is that what you were just saying, Lyndon? 3 or 2, 1, 0. Good job. You're absolutely right. 1, 5. What? 4. Do we need to keep going? That's all we need, right? X plus 4. Y equals x plus 4. That is the slant asymptote. Billy.
Shut up, Billy.
Okay, what's the domain? X cannot be 5. What's the vertical asymptote? X is 5. That is the equation of the line of the slant asymptote. Then we need to factor x and x, minus 2 plus 2 plus 1. So what are the x-intercepts? So negative 2, no, it's not negative 2, 0. 2, 0. Negative 1, 0. Do we have any questions about any of that stuff? Are we going too fast? Are we okay?
Did you do X thing on the top?
Yes.
No.
Oh, there's no holes. Thank you. Now we're ready to graph it. Okay, start with asymptotes. Vertical asymptote is at 5. The slant asymptote, what's my slope? M equals 1. What is the y-intercept? Remember, that's of the slant asymptote. So we go up to 4, and it's rise over run, up 1 over 1, up 1 over 1. So it looks like this. That's the slant asymptote. And now, what are our clues? What's our helpers? How do we know what's going on? The intercepts. So my y-intercept is 0 2/5. That's right around there. X-intercepts are -1 and 2. And that pretty much gives you a picture of exactly what's happening. Follows the asymptotes. It goes down. Is this asymptote even or odd?
Odd.
What does that tell me? It's up here. That is the function. Cool? Let's try one that is 2x squared minus 4x minus 16, 3x squared plus 9x minus 30. We need domain, poles, vertical asymptotes, horizontal asymptotes, slant asymptotes, x-intercepts, y-intercepts. Is that everything? I think that's everything. Okay, the easy one to tell right now. The y-intercept, right? Well, how do we find the y-intercept? It's just that, right?
Yeah, and then you flip it.
So 16 over 30, negative 16 over negative 30.
8 over 6. Wait, what? Yeah, 8 over 6.
So 8 over, yes, 0 over 0, 8/15. Does anybody have any questions about that?
No, you took out.
I reduced.
Oh, you reduced the 16 and
16 over 30, divide both the top and the bottom by 2.
So if they both don't have x's, that tells you the second, right?
Yes. Because x's go away because they're 0.
So do you break it down as much as you can?
Yes.
So you have to divide both of them by the same number?
Yes.
Do you rewrite it?
Yes. I don't know what you mean. But sure. What case is it?
The number beyond that.
It's beyond this, so what is it? What is the... So, is there a slant asymptote?
No.
Because it's case 2. Because 2 over 2.
Yeah.
What is the horizontal asymptote? Not y equals 0. That's case 1. It's the ratio of leading coefficients. 2/3. Y equals 2/3 is the horizontal asymptote. Now we need to factor everything, but look how nice we are. You have GCF everywhere. If you don't start with the GCF, it makes your world way harder. Okay? If you start with the GCF, instead of doing X games with 32, we're doing X games with 8. That's way easier. Right? 2x squared minus 2x minus 8. 3x squared minus 3x minus 10. Okay, the numerator is 2x minus 4, x plus 2.
The top?
For the top?
So you put it in X games then.
Oh, yeah, I did X games, but I did it in my head. 3x minus 5, x plus 2. How'd I do?
Good.
I do all right?
And this
Does anything die?
Yes.
X plus 2 dies. So what does that tell me? It means I have a hole. What is the hole? What is the X value of the hole? Negative 2. We have to find the Y value. 2x minus 4. 3x minus 5. This is the reduced, because x plus 2 died. I need to put negative 2 in for x. Don't forget the leading coefficients, the GCFs. They make a difference right now. Okay, negative 2. So 2, negative 2 minus 4 over 3, negative 2 minus 5. Negative 2, what's negative 2 minus 4? Negative 6. So negative 6 times 2, that's negative 12. Negative 2 minus 5 is negative 7 times 3, negative 21. So the Y value for the whole is 12 over 21.
You can take out a
Oh, we could take out a 3. Thank you. You're absolutely right. That would be 4/7. That's much better.
So anytime it's like a fraction,
Oh, I changed it to... We're just going to run with it. So that would be, thank you. That would be 4 over 7. Yeah? I don't know why we're leaving. I don't care. The x-intercept. Please don't pack up. You guys are driving me crazy. You got lunch right now. You can wait 1 second. The x-intercept is from the numerator. What is the x-intercept? Let's graph it. My horizontal asymptote is 2/3, so it's right here. Less than 1. My vertical asymptote, we didn't find it yet, but it is 5. My x-intercept is x-intercept is 4. It peaks right here. Looks like this.